Okay, good afternoon everybody. Make sure you've got this handout in front of you for 16K further symmetry properties. So we're going to be using the trig rate. We're going to be evaluating exact values. So we're all non-calculator here for complementary relationships. Now first we're going to define these four complementary relationships. So looking at this triangle, what we'll do is we're going to call this angle here theta. Now it didn't matter if we call this theta or this theta, but we're going to call this angle here theta, which means that if this is 90 and all the angles add up to 180, then this would be 90 take away theta, since this angle and theta are going to be complementary. So what we'll call this angle here is we'll call it pi on 2 take away theta. Now what we'll do is we're going to look at sine theta. So sine theta, we can see from our triangle, sine theta is going to be BC over AB. Let's look at cos theta. Cos theta is going to be AC over AB. Good so far. Now we'll do the same for our other angle, pi on 2 take theta. So if I think about sine of pi on 2 take theta, that's going to be AC over AB. So sine of pi on 2 take theta, which is AC on AB. But we also knew that cos theta was AC on AB, so which means that sine pi on 2 take theta is the same as cos theta. And so we're going to write that up here. That sine pi on 2 take theta is also the same as cos theta. And that's our first complementary relationship. Now let's look at this one. Cos pi on 2 take theta cos pi on 2 take theta is going to be BC over AB. Which is the same as we had before for sine theta. So we can say that cos pi on 2 take theta, which is BC on AB, is the same as sine theta. And that's our second complementary relationship. Now we'll go to the unit circle to think about sine of pi on 2 plus theta. Here's pi on 2, and let's add theta here. And so that means that the reference angle here, if this is 90 degrees, then this reference angle is going to be 90 take away theta. So this reference angle is pi on 2 take away theta. And so in thinking about sine pi on 2 plus theta, we've drawn it on here. It's going to be the same, because this is pi on 2 plus theta, it's the same as sine pi on 2 take theta, and because it's already in the sine quadrant, it stays positive. And we know that sine pi on 2 take theta, that's cos theta. So in fact, sine pi on 2 plus theta is the same as sine pi on 2 take theta, which is cos theta. And that's our third complementary relationship. For the last one, cos pi on 2 plus theta, here's our angle. It's the same reference angle. So we can say that cos pi on 2 plus theta is equal to cos of the reference angle, which is pi on 2 take theta, but only sine is positive here. So it's going to be negative cos pi on 2 take theta. Previously we saw that cos pi on 2 take theta is sine theta, so negative cos pi on 2 take theta is going to be negative sine theta. And that's what we can write here. We can write that cos pi on 2 plus theta is equal to negative sine theta. So that's us proving our four complementary relationships. They're going to come in handy. Let's look at a few examples. So here's the first example that says sine theta is 0.3, cos alpha is 0.8. Find sine of minus theta. Now, the angle is not as important, but sine of some particular angle is 0.3. Find sine of minus theta. So I'll draw minus theta here. The reference angle is the same, so sine theta is equal to, sine negative theta is equal to sine theta. I just have to consider positive or negative, and it's in here where only cosine is positive, so this is negative. So my answer is negative 0.3. Pretty easy. Over here, find cos of minus alpha. So alpha was here. Minus alpha is going to be here. And so I can say that cos of minus alpha is equal to cos of alpha, because it has the same reference angle, but cosine is positive here. So the sign will stay the change, so my answer is 0.8. Over here, find sine of pi on 2 take alpha. We're going to go to our complementary relationships. And we know that we know that sine of pi on 2 take alpha is the same as cos alpha. And of course they told us that cos alpha is 0.8. Let's look at the second example that says that given that theta is in quadrant 1 and cos theta equals sine pi on 8, find the value of alpha. Find the value of theta. So what we want to do is, in this kind of scenario, pi on 8 we're not super familiar with, let's try and make it in terms of cos. Now we know that cos theta is equal to, let's do it the other way around. No. We know that sine theta is equal to cos pi on 2 take theta. And so what we need to do is, at the moment theta is pi on 8. I want to express it as pi on 2 take theta. So what we'll say is that at the moment pi on 8 is going to be equal to pi on 2 take away some kind of angle, and we'll call it x. Which means that x is going to be equal to pi on 2 take away pi on 8. Which means that this is 4 pi on 8, and that's pi on 8, so this will be 3 pi on 8. And so we can say that sine of pi on 8 is the same as cos of, what have I done here? Sine pi on 8 is this, so x is 3 pi on 8. That sounds good. So I can say that sine pi on 8 is equal to cos of pi on 2 take 3 pi on 8.